All right. Well, good evening, everyone. Let's turn that one off. Yeah, thanks for coming out. Welcome. This is the First Friday Astronomy event hosted by Boise State Physics. If you've never attended one of these, you're very welcome here. These are a monthly lecture series that take place on the first Friday of every month. We picked First Friday, by the way, because it's alliterative. It was easy for me to remember. That's why these happen on that day. So first Friday of every month, 7:30 p.m. all throughout the calendar year, even if we're on break. My students still have to work out front. So this happens all year round. We bring in an astronomer, a space scientist. We've brought in space policy people, space journalists to come out and give some kind of lecture about space science in one form or another. And then if the weather is clear, we'll do some stargazing. We're not going to stargaze tonight at the observatory. That is actually down for repairs. We'll be out on the quad. So if you go out of this building and hook a left, there's a big grassy area just to the east, just to the west of here. And our students will be out there with some telescopes doing stargazing after the lecture. And speaking of the observatory, we actually have a fundraising campaign right now to refurbish it. So the telescope and the mount that are in the observatory right now are actually relatively new. The mount is only a few years old, but the dome itself, that old ash dome, is almost 50 years old at this point, and so it does need to be updated a little bit. And so we've raised already $110,000 through so a lot of very generous folks, some of whom are in the room here. We're 91.92% of the way there. So if folks are interested in supporting this effort, you can visit our Pony Up page. Pony Up is Boise State's crowdfunding platform. And so the easiest way I think to find this is you can just Google Boise State Observatory Pony Up, and that website will come up. And you can make a donation to help support this effort. The hope is that we'll be able to start the contracting process. You know, it's a state agency, so these things always take a lot of time. Start the site contracting process this fall, with the expectation that probably late next summer, early in the fall, we'll have this observatory refurbished and available again for public viewing. So yeah, that should be a really great project. As part of this effort, in fact, I think it's described here. Donations of $1,000 or more, you'll be invited to join us for our November First Friday Astronomy event, when we're going to, this is next month, of course, when we're going to host Dr. John Mather, who is the winner of the 2006 Nobel Prize in Physics. So he's going to be here on November 1st for the first Friday that month. So $1,000 donation will get you access to the pre-talk reception that we're hosting for him. So you get to rub elbows with a Nobel Prize winner, and then we're hosting a dinner for him for $5,000 the night before. So actually on Halloween night, we'll have Mather and have a very nice dinner downtown, and you'll get to I don't know, ask him all your weird physicsy questions and get it from the horse's mouth. Mather's Nobel Prize was won for his work with the Kobe mission, which was a NASA mission back in the 90s to map out the cosmic microwave background radiation. And it was the first mission to do that at high resolution, and taught us about the Big Bang and the earlier expansion of the universe. So he won the Nobel Prize in Physics for that in 2006. So it's a really amazing result. He's been such a nice guy. We've been emailing with him for the last couple of months. He seems very down to earth. So it should be a very fun event. And if you can help donate to make this happen, you'll be able to join for one of these private events. Okay. So with that, let me introduce tonight's speaker. Oops. I have my notes here. So we're very fortunate tonight to have, of course it's going to reload the page. Yeah, I gotcha. I try to do one screen at a time. Thanks. And it looks like your laptop has gone to sleep. Ready to plug it in. Should be plugged right here. Switch back to the screen. We'll find out. Sorry, give us a second, folks. No, you were gone from the Zoom. Oops. Give us a second to reboot the computer. Oh yeah, what else is happening? Oh, I'm Brian Jackson, by the way. Those of you who never met me before, I'm a physics and astronomy professor here at Boise State. I've been here for 10 years as of this July, so it's hard to believe. My daughter, who is 11, does not, she was born in Maryland. For her, this is home. Boise is home for her, so she's never lived anywhere else as far as she knows. That's a little strange for me because I grew up in Georgia. So to have a daughter who's from the Pacific Northwest is kind of a surprising thing. It's not something I would have expected. So yeah, it's a little bit strange. Let's see, what else can we talk about? Any stand up? I don't my type 5 down. Wow. So yeah, so we have First Friday events all throughout this semester. I was just talking with someone in the audience. If there's a topic that you would like to hear about, feel free to get in touch with us. You can just Google me, Brian Jackson, Boise State, and my website will come up. And I think some contact information out there on the table. Get in touch with us and let us know. There's a topic you want to hear about. We can usually bring a speaker out to talk about that topic, and we have done that before. If there's a request, we can honor those requests very often. People like Boise. They like to come out and visit with us, so we don't usually have too much trouble getting people to come out, as it turns out. In fact, John Mather, I don't know if I already told this story, but John Mather, I emailed him, I think last fall, not expecting to get a response, just emailed him out of the blue. Dr. Mather, we'd love to have him come out. And a week went by and I thought, well, okay, I didn't expect anything. And he emailed 7 days, I think, to the day and said, oh, I'd love to come out to Boise. I have a cousin out in Boise, so I'll just visit him while I'm out there. So that's what brought him out, his cousin. So I guess let us know if you know some sort of famous astronomer who happens to have any relatives in Boise. We can probably bring them out more easily that way. Oh, and we should also highlight our astrophotography calendar. I see some of you have purchased one. Our students put together this really lovely calendar of astronomical observations that they collected out in the Dark Sky Reserve from here on campus. It's 12 months, 2025. Each month has another picture that was taken by one of our students or one of our partners in our program. So it's beautiful, $25 out there, really great stocking stuffer. So highly suggested, it's really beautiful. And that money actually goes into this observatory fund. So it helps to pay for the observatory refurbish. So let's see, do we need to put you back in? We're gonna have to make you a co-host again. Okay. You did? Yeah. Good.
So I'm just loading up, and we're ready to go. If anyone wants to fund me getting a new laptop, it would be really cool too. $2,000. Take it.
Okay, I'm on this PC right now, so you probably won't see your screen.
It's just not coming up on my laptop. Oh, like it's, you know what? You're right. You're right. Okay, so it's probably, yeah. Okay.
You remember how to do all this stuff?
Yeah. This just needs to go over there, and I just need to see that screen to
Sure.
resize it. Thank you, everyone, so much for your patience.
Yeah, believe me, the talk is going to be worth the wait. Talk is worth the wait. Okay, lovely. Okay.
Then I'll share.
Share your screen. Lovely.
Brian,
Yes.
who is your assistant?
Which assistant? Oh, I'm going to introduce, this is our speaker.
Oh,
I'll introduce her in a second. See that anticipation, it just, it makes it so much better. My assistant.
It gets me a laptop.
Yeah, that's good.
Okay. We should be all set.
You good? Okay,
Yeah.
excellent. Let me tell you who my assistant is.
very good.
Yeah, this is Dr. Lindsay DeMarchi. Dr. DeMarchi received her PhD in astrophysics from Northwestern University, where she studied transient phenomena. Before that, she got a master's degree in physics from Syracuse University. And then before that, a bachelor's degree in physics and astronomy from Colgate University. Most recently, she was an IEEE fellow, right? And works on Capitol Hill, helping to design space policy. I think you'll hear about some of that tonight. We had a really interesting talk this afternoon, in fact, on her space policy work. And so I think this is a talk you're really going to enjoy a lot. And she was our 2023 astronomer in residence in the Central Idaho Dark Sky Reserve. So she did a fantastic job doing outreach out there. And so we were very fortunate to be able to bring her back for this talk tonight. So with that, let's welcome Dr. DeMarchi.
Okay. Thank you, Brian, and thank you truly so much, everybody, for being here, especially parents who are visiting. I know it's been an exhausting kind of series of events, so thank you so much also for sticking it out on a Friday night. As Brian said, I'm Lindsay. This is a talk that's, in essence, an update on your sky. And there's a couple reasons I wanted to do this, and I think the most obvious is the fact that I'm 30 years old, and the first time I saw the night sky was last year when I did the Astronomer in Residence program, which is crazy because, you know, I've been around a little bit, but also because my background, as he said, is a decade at least in astronomy, and still never saw a dark sky in person. So I think that's something that you all have an incredible reserve out here that should never be taken for granted. And whenever I share this with people, especially if they grew up in a more rural area, they're shocked. Like, how could you have ever not had a night sky? But a lot of us don't grow up with one. And so I kind of created this talk to give people a little bit of an update, whether you do or don't look up. This is what's currently happening, current events in your sky right now. Also, before I start, there's a couple shout outs I really, really need to give. And the first one is to the whole Boise State community. Not just the Astronomer in Residence program truly changed my life, and everything I took from it went with me on the Hill. But what's crazy is that even when I was on the Hill, I kept meeting the Boise State influence all the way in DC. So what happened was I was sitting in my office in the Senate, and a funding bill came out in the House. And I was reading through it to see what science funding had been accepted. And there was a line in the bill that said X amount of dollars goes to the Central Idaho Dark Sky Reserve. And I literally jumped in my seat and I screamed to my office mates, "Oh my God, someone talked about the reserve. That wasn't me. I don't know who did that." And so I'm thinking, oh my God, there's someone on Capitol Hill who also knows the Dark Sky Reserve and cares about it like I do. I have to meet them. And I was so excited, I immediately emailed Dr. Jackson and said, "Did you know somebody did this here?" And he very nonchalantly was like, "Oh, I didn't know that went through." And it turns out it was Brian's activism that did that. So it was incredible, really great. The second piece of Boise State influence is, which I will elaborate on kind of through this talk, is I wrote a bill called the Dark and Quiet Skies Act. And I worked in Senator Hickenlooper's office. He's a Democrat from Colorado. And to introduce the bill, we wanted to introduce it bipartisan because it's a bipartisan issue. It doesn't matter where you are, you want to see the night sky. Which again, I'll elaborate on kind of the meat of that act, but I wanted to introduce it with a Republican co-sponsor. And it just so happens that Idaho has 2 Republican senators. So I cold emailed them. And the crazy thing nobody knows about the Hill is that it's all 22 to 24-year-olds. Most of you or your kids are the age of Hill staffers. So I was one of the oldest people in my office. And I just cold called that office, had no idea what the reception would be. I got an immediate response when I said I spent some time in Idaho. And it was a Boise State alum who had graduated just 2 years ago, who was on the other side of that email chain. We got coffee to see, you know, like, what's the vibe? Do we trust each other? Can we go in on this? And it was not just an effortless friendship, but on that same day, one of the AstroTac members, who's sitting in the back, Ariana, much to the encouragement of Chandler, who was sitting next to her, was texting me pictures from in the reserve of pictures of space with satellites in them, because this is something that I like to collect to show people. It was that day I was talking about this topic with that Boise State alum from Senator Crapo's office. And I said, the best way to explain this to you is to show you what I just got texted today. And I handed him the picture that she sent me. And once he understood that that wasn't a crack on my cell phone screen, he immediately understood the issue that we were talking about, and he agreed to sign on the bill. And with 2 weeks before recess, we introduced it together in the Senate. So because of him, the Dark and Quiet Skies Act now exists. And he came to visit Boise State just a couple weeks ago, I want to say. And he cares so much about Idaho and doing great things for the university. And that wouldn't have happened if there wasn't a community of people who left him with that feeling. So thank you from me for creating the environment that we have. The last shout out I want to give is to my Stanley family, and I'm sorry to embarrass you, but there's a couple people here all the way out from Stanley. And the entire time I was on the Hill, they were in a group chat encouraging me to keep pushing. So also thank you for everything that you did the whole year I was on the Hill. Okay, all of that aside, let's get into the fun of the talk. It's October. This was going to be a talk about with like a cool thrift theme. I'm not doing that. I'm just going to do a Halloween theme this time. These are all images from 19-teens horror films, silent films. I'll give the credits at the end of who this one director is, but there's really cool visuals that I stole from his movies. I hope you enjoy that too. Anyway, this talk is about mostly common questions I get that I had going into the Hill, but also questions I've gotten here throughout my astronomer in residency. And it boils down to who owns the sky? Who governs the sky? What are shooting stars that don't go away? This is a question I got after a talk I gave in Ketchup. What is happening in space? What's the near future? And what are my options to participate? But this talk is also about the public that is viewing the sky. So who is the public to me? I'm a scientist. I'm going to walk you through what the public means to me. And to do that, I'm actually going to zoom all the way out to a cosmic scale and start with the cosmic calendar. Some of you may be very familiar with this because I think Carl Sagan was probably the first person to really popularize this. I'm going to map the history of the entire universe to a calendar year, which starts with the Big Bang on January 1st, 14 billion years ago. And when the Big Bang happened, it was just a lot of positive and negative particles every which direction, very hot and energetic. And eventually, by cosmic March, things start to cool down enough that stable structure can survive. So you start to get things like galaxies and the Milky Way 11 billion years ago. So it took about 3 billion years-ish to get to that point. When you have a lot of positive and negative particles flying around, you put them together and you actually get hydrogen. Hydrogen is one positive, one negative, and one neutral particle put together. So the universe is made up of a lot of hydrogen. And a couple times, if you smash hydrogen together, you may end up with helium here and there. 1 + 1 = 2 on the periodic table. And that is helium, which comes next. And it's kind of funny to say this because we're running out of helium on Earth a little bit, but helium and hydrogen are the most abundant gases in the entire universe. Pretty much everywhere you look, this is what you'll find. But we still have the rest of the periodic table somehow. So the Big Bang, for the most part, creates this hydrogen and helium. Where does the rest come from? Stars. When I started my degree, I was actually really bummed to learn that I had to study stars. I genuinely thought there was nothing more boring than these like orbs that kind of do nothing. I wanted to get to the exciting stuff like black holes and whatever. Stars are actually very busy throughout their entire lives. So this is a cartoon cutaway of a star. And like I said, much of the universe is hydrogen and helium. So all of the yellow in this sort of cartoon here is hydrogen for the most part. And in the center of a star, it is so compact and so dense that this hydrogen smashes into each other. And that's where you start to form helium. The important thing about that is you're doing fusion, which creates energy. So this fusion is creating a pressure that goes outward, while the omnipotent force of gravity is trying to crush inward. And for a star to exist as a stable sphere, there's a balance between this gravity and this pressure. And that's why stars can exist as they do for so long. And in the core of the star, you are crushing together new elements. And so stars will do this for billions of years until they create carbon, nitrogen, and oxygen for the most part at the center of their core, depending on the size of the star. So as a quick sidebar, I said that this was about defining who the public is to me. Materially, the public, you all, are made of carbon and water. Water is H2O, so that's hydrogen and oxygen, as well as carbon, which is C. The conclusion here is that you, me, everyone we've ever known, we're all part of a different star that existed before our sun. We were made in the center of that star that had to have died. And then our new star came along and formed, as did the Earth and everything from that point on. It still doesn't explain really the rest of the periodic table. What ends up happening is that a star runs out of this fuel once we get to carbon, nitrogen, and oxygen. I've highlighted silicon here. When we start to run out of carbon, nitrogen, and oxygen, the crush of gravity wins over the lack of pressure. If there's no fuel, there's no more pressure. And so it's kind of like a trash compactor. And at the very center of the star, where everything is closest together, it reignites a new chain of fusion in this moment where gravity crushes it momentarily. And in a matter of hours, literal Earth hours, a star will fuse silicon all the way up the periodic table to iron, literally in hours. So everything else took billions and millions of years. Now hours, we get all these elements, which includes the calcium, that is potassium, thank you. Potassium in our bananas, calcium in our bones, and chlorine in our pools. So not only did we come from a dead star, everybody together, but there was also this crazy couple of hours where all the other stuff around us formed. Genuinely incredible. So coming back to the cosmic calendar, our previous starhood together is somewhere between March and August. And around August, 4.5 billion years ago, the sun and the planets around it form. September-ish, 3.5 billion years ago, is the first life that we know of. October, the Earth's atmosphere starts to oxygenate about 2 billion years ago. November, we start to get complex cell life, and December gets so busy that I'm actually going to zoom in. I don't expect you to read all of this, just some highlights are that dinosaurs appear on Christmas, and then the day after we have mammals. And if we were to look at the oldest settlements of anatomically modern humans, that's about 8 minutes of the cosmic calendar. If we were to think of, well, I guess the Great Pyramid is a good example of something truly like ancient, but still like civilization and culture. That's 11:59:49, so 11 seconds before midnight. And it's not until 1 second before midnight, Columbus arrives in America. And so kind of around that time is like Middle Ages, Renaissance, 1492, kind of in that area, give or take 100 years. So a lot of the history and architecture around us are just a blip in cosmic time, something to the tune of 1 second before midnight. I mentioned that we've been here since that star that we all kind of were before. But the truth is that we've actually all been here since January 1st. You cannot create or destroy matter. It just changes forms. So it took, very literally, this purposeful alignment of billions of years of interconnected actions, like butterfly effects kind of throughout billions of years that brought you together now in this room, along with everything else teeming with life. And so when I think of the public, I actually also take a moment to say, yes, it's people, but it's also everything else that originated from the same building blocks. You just change something like biome and temperature, and life has flourished in infinite ways to interpret being alive. This is an interlocked set of immaculate, diverse ecosystems that all depend on one another without boundaries, right? This is a chain of life cycles and circles and endless synergy relying on success, demise, mistakes, habits, death, birth, waste, pollination of one another. That's kind of a conclusion in and of itself, is that nature is truly amazing. And just to add kind of one more incredible statistic to the pile, as if you didn't already feel special, if we just look at humans, our DNA has about 7 times 10 to the 13 different possible combinations it can make. That's 7 with 13 zeros. But if you try to count up all the people who have ever lived and ever lived, ever died, or are alive on the planet right now, you would get 1 times 10 to the 11. So that's 13 zeros versus 11 zeros. The way to interpret this information is to say, there has never been a person like you in the history of existence, and there probably never will be again. So I dive deep into this in my innermost self the moment I need patience with someone. I'll be honest. Sometimes it works. So that's the public to me. And we know this because we study the cosmos, particularly dying stars, actually. So a tagline that sometimes I'll use is stellar mortician. And it's not just because I'm very spooky and I like spooky things, but it's also because my PhD work was in dead and dying stars, literally teasing out how do stars die and the role that gravity has in that process. And to do that and to look at the rest of the universe, astrophysicists will use the whole electromagnetic spectrum, which is different types of light all at once. So to give you an example of what that looks like, this is an example of a dead star looking just with visual light. But if I was to look at the same star with infrared, like in an infrared camera, which on the left here is kind of like a heat signature of a person, same idea. This is what that same star would look like. Now, radio waves, gamma rays, ultraviolet, light comes from the sun, and X-rays, like the figure on the right, the cutaway with all the bones, same thing. And you can actually see here, that's a black hole with energetic jets that's at the center of that dead star. That to me was not obvious with just visual rays. And if I put it all together, I get this glorious sort of composite image. And what's kind of crazy, I was thinking, like, how am I going to explain this just in like a really quick, accessible way? And for some reason, my mind went, well, what if you could see a person's heat signature, bones, and skin all at the same time? Which is a really horrifying image to comprehend. But you would learn a lot about a person kind of instantly if you were able to do that. You could see if they were stressed, you could see if they brushed their teeth, all of it kind of all at once. And that's what we do when we look at the universe. Supernovae, for the most part, actually happen very far outside our own Milky Way galaxy. It's actually a mystery right now. We're in the cosmos, we're about 100 years overdue for a supernova within the Milky Way, and people don't actually understand why. So for the most part, we get our supernovae from very, very distant galaxies. I shouldn't say for the most part, entirely. That's where they come from. So this is an example of a distant galaxy. It's called M106, and it's located 22 million light years away from Earth. This is an image of infrared and X-ray put together. And if I turn on, I'm sorry, infrared and visual, and if I turn on X-ray, you discover that it's got these extra arms in it, which is kind of cool. And if you look, I'll turn them off. You can kind of faintly see them, but it's not nearly as obvious unless you were using X-rays. Why do I show that? Because every single speck here is a star. And every glowing region is a lot of stars put together. And I double checked this with an expert named Brian Jackson this morning. Every star is thought to have at least one planet around it. So for our exercise, I'm going to take M106 and rotate it. And I'm going to do like a little, like, let's pretend we're observing M106 demonstration. So I swear this is still M106, just a worse photo. But this is what it might look like if you were looking through a telescope. And I'm going to zoom out. And as I do so, just take note of some of the smudges and oblong shapes that aren't quite circular. Those are other galaxies. Farther away, maybe different shapes. Galaxies come in about 3 different shapes. If you zoom out all the way, we see a few more galaxies here and there, and all those specks of stars are actually in our Milky Way. They're in the foreground. We keep zooming out until we see the dark night sky, which you would never know these treasures were hidden in there because it kind of all looks like the same few specks. So I'm going to zoom back in and pretend that we're looking at M106 through a telescope. So if I do so to do some science on it, I'm going to rotate it again and take that observation. If I were to look at M106 right now, this is what I would see. And we get to one of the questions that was at the beginning of my talk. What are those shooting stars that don't go away? Those are satellites. So this is an image of the same field of M106 with satellites through it. Satellites are made of metal, which may sound obvious, but the operating issue with that is that they reflect sunlight because they're made of metal. And so they are bright. And if you take a long exposure photo as they're moving across the sky, it creates a trail of light through your image. Satellites orbiting our Earth, for the most part, were put there within the last 5 years. A few hundred of them were launched in 2019. And so I'm going to play a time lapse for you of how this has changed in the last 5 years. I'll note that this is not to scale. Satellites are a lot smaller than the Earth, but I want to give you a sense of the coverage of the satellites as it stands and the amount of sort of latitude and longitude over the globe that it covers. So that gets us to about February of 2024. If this seems sudden to you, it's because it is. This is a function of number of satellites as a function of time. So it's a sort of histogram or tally of how many satellites are in orbit. And satellites first came into orbit around the Earth with the launch of Sputnik in 1956. And since then, it's mostly been government missions and spy satellites. Kind of cool, but that's what it's mostly been. And a few science missions, right? But it's not until 2019 we started launching hundreds of satellites at a time. And those of you with a keen eye may have noticed that the picture I was showing you with the satellite streaks in them is from 2020. So in 2019, there were about 3,000 operating satellites in low Earth orbit. Today, that number is about 10,000. The longest SpaceX went between launches last year was 11 days. They average a launch every 4 days. And when they do, they deploy about 20 satellites at a time. And industry affectionately refers to this as a Pez dispenser in low Earth orbit. There are plans for 530,000 satellites. I've seen some estimates go up to 1 million, but this is, I think, a more reliable number. To accurately illustrate that on this graph, I would have to extend the graph way above the ceiling. That would be by the 2030s. Thank you for asking. So to show you exactly what in this field of view is obscured, I'm actually going to turn on some annotations made by the photographer. Everything with NJC in this photo is another galaxy. And you may notice that there were galaxies that you didn't pick up on the first time when I was zooming out. They're kind of tiny and they're very distant. And some of them are actually the width of these satellite streaks. So a very, very fair question that I get a lot is, well, can't you just wait till the satellites are not in the field of view before you take a photo? Fair question. I come from a field that's called transient astronomy or time domain astronomy. That's the jargon. And what that means is time is a very valuable aspect of what I'm doing. There are some phenomena, like when a star dies, that you cannot repeat. It cannot happen again. And you need to capture at the moment that it happens. And sometimes that can take milliseconds. So you don't really have a lot of flexibility in my field when you get to take a photo. If something's exploding, you can't tell nature to wait. You got to go look. So sometimes it is okay. If I'm looking at galaxies, they're not really going anywhere. But if you're trying to get after real hard, like cutting edge science that's happening very quickly, you don't always have that kind of flexibility. So in that spirit, this is unrecoverable science if it's underneath a satellite streak. When I was talking about this issue with the senator, I had probably about 30 seconds to explain what I just said for most of this talk. So I showed him this image here. On the left is supernova 2019 EIN. It's this little speck over here. So when a supernova dies, or when a star dies, for a month or so, it outshines the rest of its galaxy. So that's why you're actually able to see it. That's one little star in the grand scheme of the rest of that galaxy. So it exploded, and somebody took a photo for science. And that was in 2019, May 15th. A couple weeks later, not even, May 23rd, that same year, 2019, a couple Starlink satellites were launched to that orbit that covers that field of view. And they went back to take more photos, and this is the photo that they got on the right. And I think that what's really important to highlight here is not just that the satellite streaks are about the same size of the supernova, but that it also causes the camera to saturate a little bit, and you're not able to get the same level of sensitivity to see deeper into space. So sure, you could argue that that supernova wasn't totally obscured good, but number one, I might trust that data a little bit less because I don't know how much spillage there was from the other things in my foreground. And number two, I've completely lost anything else I might want to see that's farther away than that. Industry is very well aware of this issue, and I know that for two reasons. Number one, they tried to think about it before they launched. So here's a tweet from Elon Musk in 2019. There are already 4,900 satellites in orbit, which people notice 0% of the time. Starlink won't be seen by anyone unless looking very carefully, and will have 0% impact on advancements in astronomy. We need to move telescopes to orbit anyway. Atmospheric attenuation is terrible. And a Google image of how many satellites are in orbit. These are tweets from colleagues of mine in 2022 and 2023 of science with satellite streaks through them. And I want to bring up this element of time sensitivity once again. My colleague on the right was trying to take a picture of a new comet that came out of the Oort cloud. And she said, luckily, it is just below the satellite streak and was averaging a streak every other minute. I'm sorry, every other image at the moment. I'll remind you guys that astronomers are paid by taxpayer dollars, and this is sometimes science that has to be thrown away. So in a very real sense, sometimes these images are thrown out, and it's a waste of money, unfortunately. But I think the more pressing issue is that if that satellite streak had covered the comet, she wouldn't be able to tell where it was for a moment and may miscalculate its trajectory. The second reason I know that industry really knows this is a problem is because they've already tried to fix it. So this graph here that kind of looks like a mess, at the very, very top is a batch of Starlink satellites that were kind of the first to launch. And what you're looking at here is a count of how many there are. And along the x-axis horizontally is how bright they are. So astronomers use something called magnitude, and I've put a big red bar for where naked eye limits are. So at that red bar is like the faintest your eyes can see, and to the right is brighter. So you can tell for the most part, most of the Starlink first generation were much brighter than the naked eye. So you don't even need a telescope. Starlink V1 visor sat, which is the one underneath that, is when Starlink tried to paint the fuselage darker, because I mentioned it's made of metal and that reflecting is a problem. So they gave it a real honest effort. I'm not even being dismissive when I say they tried to paint it darker. I mean, like they really tried to R&D the heck out of this paint and really get it to work. And it did make some of them fainter. This is a new generation, so I should say that the brighter ones are still up there. With their next launch, they tried the next best thing, but a lot of them were still brighter. It wasn't a cure-all. So truly, they are putting their own money back into the problem to try to fix it. I'm very well aware. The other reason I know is because when I was working on the Hill, nobody knew I was an astronomer, right? So they didn't have to be nice to me. And I did have many people from industry coming to me and saying, I want to be part of the solution. I want to fix this. So it's not for want of trying. It's actually a very difficult technical issue. And the last thing I'll say about time sensitivity, because I get this question a lot, is what about meteors or meteorites? So we don't go the way of the dinosaur. People are really worried about that. And I can tell you as a scientist, I don't know that you need to be worried about that among other things happening. But to put your mind at ease, it is something scientists think about, and it is something scientists study. So to do so, they look at an image like this. I know it's hideous, but these swaths from the bottom left to the upper right are star trails. So this is a long time lapse. The crazy hatches in random directions are meteors. And in the foreground, this sort of extra swath that goes across the front, kind of looks like guitar strings maybe, or violin strings, but a lot of them, is a satellite constellation. So if your job was to count how many meteors are in this image, I would have trouble doing that with confidence. There's also something to be said for the heritage that's lost from visible satellites. It's becoming increasingly difficult to escape man-made anything. So I, again, really need to shout out the AstroTech here. These are images that I've gotten via text from the AstroTech. Ariana and Chandler, who are in the back, have sent me these. And these were all taken in the reserve, some of them with telescopes, some of them with cell phones. And the upper left corner here is the one that Ariana sent me the day that I was meeting with Senator Crapo's office. And if you saw the calendars out front, it has its own month. It is a very special image to me, so I will be framing it. So this is just, a little bit more towards that, how it's really in our own backyard at this moment. And I do want to encourage you all the same way that I encourage most people. If you do astrophotography and you are currently editing out satellites from your images, please don't, because your images are the way that most people understand what space looks like, because they can't see it in their own backyards. And so it kind of becomes almost a deceptive view of what the night sky looks like. And so to that effect, I've compiled some of my favorite images of people who have not edited out satellites from their photography. So you may recognize that is the Horsehead Nebula on the left and the Andromeda Galaxy on the right. I'm not by no means Twitter famous anything, but I posted this image. I didn't even take it, of Andromeda, and I got a lot of hate online because people were telling me that I don't know how to do astrophotography. I think people are shocked to see how much it is really up there. Yeah, sure. Was which image? Let me. Say we're not getting rid of color? Yes. So you're okay, let me see if I'm paraphrasing this correctly. You're saying if it's now a black line instead of a white line, it's not fixing the problem. I 1000% agree. I let me actually talk on that for a minute because that's an extremely good point, right? One of the central themes of this talk is to mention compromises, and this is a compromise that some people have made, is to say, okay, astronomy aside, science aside, just people out in the wilderness trying to look up at the sky, painting it darker would probably do better to preserve some of that heritage. It does not help the science. So an example that I like to use with people is if you go to a national park and there's a gorgeous mountain and you're trying to take a photo of it, but there's a group of tourists in the way, you don't care what color t-shirts the tourists are wearing, right? They're in the way. Yes. I 1000% agree. And I actually have some backup slides here that show these other wavelengths, how painting it black doesn't necessarily help at these other wavelengths. For example, you go outside in a black t-shirt, you feel a lot hotter in the sun, right? So your heat is infrared. So if I was to actually look at the sky with an infrared camera, these new satellites that have been painted black may actually be so much worse in the infrared. So you're kind of also kicking the problem to another wavelength by painting them, unfortunately. So thank you very much for bringing that up. So what are all these satellites? I think is a very valid question. Why do we have them? They contain internet providers and competition for those services, as well as this new sort of thing that's kind of rolling out right now that's called direct to cell, which is your cell phone, instead of talking to other cell towers, now talks directly to satellites. Not all cell phones are doing this right now. This is like a new technology that they're trying to do. And GPS, which is irreplaceable, I think. Other countries are now launching way more satellites. So China just launched one of its mega constellations called Thousand Sails. They are currently brighter than the Little Dipper. Remote sensing, it's a very fancy way of saying that we actually point the telescopes down and look at the Earth, and we use that for climate change data. And other scientific missions, right? Like the International Space Station, which I do mention. So I'll also take a moment to say that one of the things that surprised me to learn, so I'm an astronomer, my background in astronomy, my research was funded by NASA grants. So I thought surely NASA would want to know that this is happening. NASA at the same time, I'm sure does care, but is also putting out grants for commercial destinations in low Earth orbit, which is kind of a wordy way of saying, let's get industry to put things in low Earth orbit. And we as NASA can be a customer and do our science. So it's kind of in the wake of uncertain funding, becoming an issue where NASA can't always deliver on its own sort of goals, and they're looking to industry to kind of offset some of those costs. So they say to industry, if you can get to space, we will be a customer on whatever you do in space. And kind of to that effect, there is a company right now called Sierra Space that is making a mixed-use business park that will be in outer space. And I have seen that successful testing of some of that stuff. That's a great question because no one wants to share those numbers. So excellent question. I honestly don't even have a guess. Yeah.
Satellites aren't function for also people died out, just kind of like space junk and everything. But does that have any influence on climate change?
That is a really, really good question. And I think I'll have to leave it to, I'll say we don't know, but I'll tell you why it's a we don't know. That stuff that's no longer in service or usable or directable because we can't, for various reasons, maybe it's run out of fuel, whatever, has to come back down. And as it does so, it'll burn up in the atmosphere. So there was a study that came out that there is an anomalous abundance of heavy metals in the atmosphere that has been attributed to satellites because it matches the same ratios. Unfortunately, that one study it's just so cutting edge that there's only been one study. And I know because I cold called them to learn more. I was knocking on that email box, tell me all about that research. They have another 2 missions planned. So that took place kind of in the Arctic. And they have another one at the equator and another one, I think, towards the Antarctic. And they want to draw large scale connections by putting those studies together. This is how it's affecting the atmosphere as a whole. So the consensus, the I don't know, is everybody agrees it will have an effect, but nobody knows how much or what. Yeah, great question. I'll also add that Starlink is built to deorbit every 5 years. So these satellites will come back through the atmosphere. In addition to the defunct stuff that's up there, the functioning things were made to be disposable every 5 years. Which I think is a great segue. Who's in charge here? Not obvious, right? So the first one I brought up was NASA or NOAA, which is another group that uses some of this data. That was my natural thought first. They will send things to space, but they do not regulate. They do not want to regulate. They don't want to follow up on consequences with that. That's not their responsibility. So I went into the Hill thinking the president's in charge of the country, right? I forgot about checks and balances. I have not taken a civics class since the 6th grade, I'll be the first to admit. So it turns out the president is not in charge of the country. But the president, through an executive order in the Trump administration, did say we have to keep sending things to space. It's called Executive Order 3 or Space Policy Directive 3, something like that. So I also thought, okay, maybe one level up, who's in charge of the president? The UN, right? The UN actually has an agenda item that they have to talk about every time they meet about dark and quiet skies, which is pretty cool. But unfortunately, the UN is not in charge of anybody who's a member of the UN. So it's not like the UN can police the United States about anything. But they do have the only law in outer space, which is a treaty, and not everybody has signed it. And it's please don't have nuclear war in outer space for the most part. So I'm actually very glad that it exists. Like if we've got to start somewhere, that's a good one. Companies that are there already, do they have squatters' rights? In a sense, it's very powerful, the influence they do have. They set precedents, and anybody who's ever tried to change policy knows that the status quo is very strong. So if you start to establish a status quo or a current, changing the tide of that current is very hard. And they also define what's capable. So I mentioned before that SpaceX knows that this is an issue, and they tried to paint their satellites, and it didn't work. So Congress is not going to want to make a law and say you must be dimmer than the naked eye if no one can do it. So unfortunately, they do set the tone for what's possible. And I say unfortunately because I wish that there were more resources towards this that were more dedicated, which is a plug for the Dark and Quiet Skies Act, which I will mention. It's to get kind of after that exact issue. So FCC Space Bureau, I'm sure none of you have heard of this. The FCC say you can't curse on the radio. It's the same people I'm talking about here. Why would they have anything to do with space? Well, satellites have to communicate back to Earth using radio frequencies. And in the actual text of what the FCC is supposed to do, there are these words, public interest. They are supposed to act in the public interest. And it is their interpretation of exactly those words that made them think space debris, satellite junk, as was mentioned in that question, is kind of a hazard to public interest. So let's make some rules as the FCC that try to limit the amount of space debris, which is a separate issue than what I'm talking, well, related issue, but not the main focus of this talk. But that's what they aim to do. And they received a lot of criticism. People were like, I agree with your I agree with what you're saying, but I don't think you should be the ones to say it. And those of you who are keeping track of what's going on in the Supreme Court, the Chevron deference was, sort of overturned in question, which gave these agencies the ability to interpret what their charge is, to interpret words like public interest. Now that's a little bit more difficult. It's more of a stretch for them to kind of use that kind of responsibility or claim that they have that responsibility. Federal Aviation Administration, FAA, this is airlines or airports and everything like that. They are in charge of going up and coming down with rockets, but not in between. So I show you all of this to show you the landscape of options and how there's a gap here. Who's in charge of space in space? Right now, no one, but there's cutting edge legislation. Like here we are right now. This is what's being talked about on the Hill right now. It's looking like in NOAA, the Office of Space Commerce, and possibly also the Department of Transportation, maybe who takes on this responsibility. And if you're interested in following this, the whole who should be in charge of space is called mission authorization. That's what you would Google, mission authorization. There is a proposal in the House, 2 proposals in the Senate, and something that came out from the White House that kind of all point to the Office of Space Commerce. The White House points to both Space Commerce and the Department of Transportation. So that's what it's looking like. Yeah. Yes, that is such a good question. No one really understands the answer to that question. Like it's really crazy to see kind of other military branches being like, why did we do that? To be determined, I think. Yeah.
This is only from an American perspective, right?
That's not indelicate at all. That is yes. This is only from an American perspective. Exactly. And that is a great point because a lot of times people will say, well, this is a global issue, so it should take a global solution, right? Because if we, as the United States, do one thing, that's not going to stop another country from doing a totally different thing and undermining those efforts anyway. So some people believe that that treaty I mentioned before should be rewritten and include some of these things. Other people think there should be its own new thing. The UN is a little tense, as you can imagine, and also can't really enforce a lot of these things sometimes. So it gets difficult too. I think as we think about this, it's important, very much in the spirit of that last question, to kind of zoom out and ask what's actually the goal that we're looking for. So this is kind of the philosophy underneath the philosophy underneath sort of the things that we're trying to make with policy. And I'm going to throw up here a bunch of philosophies that have been expressed to me by people around me, people on the Hill, people who have, thought about this for a very long time. And you may resonate with all of it, you may resonate with none of it, but this is, like I said, to get you up to speed on the conversation. So some people think American leadership in space is the most important. What if somebody else gets there before us? What if somebody else puts more things up there before us? Human colonization of space. Is it our species' implicit manifest destiny to move off the surface of the planet and populate the cosmos? Global connectivity and competitive options for that connectivity. Rural infrastructure is not great, and sometimes satellite internet looks pretty appealing as a solution. Whether or not people can afford the satellite internet is another question, but it's certainly, you cannot doubt that internet connectivity is very important. Growing the economy. Ted Cruz loves to say that the very first trillionaire will be in space. And scientific advancement. There is science beyond just using telescopes. There's something to be said for the missions that are done on the ISS, missions that are done either on the moon or on Mars with rovers. There's other science to be had too, but I would argue that if this is your primary and only goal, we are very much closing ourselves off from much of the universe. And I'll actually go back to that slide. This is not black and white whatsoever. And I think everybody's going to allocate a different percentage to everything up here and probably a bunch of other things I didn't think of. So there's no real punchline to say, yeah, this is the answer. This is what you should want. But I encourage you to think about what you might want. And so I'll just, in the interest of time, kind of go through this a bit quickly if you're interested in policy and following up. Mission authorization is the one about who's in charge of space. The Dark and Quiet Skies Act I mentioned, the meat of it is let's put government, industry, academia, and the public in a room together, give them $20 million and see if they can come up with a good tech solution. Very straightforward. Spaceports and the Astro Act. These are two different acts that kind of do the same thing, but a different stream of funding in each of them. Spaceports are like airports, but for getting satellites to space. So launching things. If that's interesting to you, there is legislation being talked about right now about where to put them. And I didn't know this before really spending time on the Hill. Agencies, when they want to make new rules for themselves, will have rulemakings. It's like having laws, but within these agencies. And they ask for public input. So you are allowed to comment on rulemakings at the FCC and the FAA. And they also have advisory committees where they will accept sometimes members of the public to oversee them. So recently, I've seen some of these topics cover satellite debris, building spaceports, and responsible actions in space. So the paths before us, like I said, are not black and white. But on one extreme, we have stop launching or limit the number of launches. Definitely heard people say that. And another person told me once, you're going to have to accept that there's telephone wires in your Westerns. I couldn't find a picture of that exactly, but I feel like this is the spirit. It's, clearly a movie about ancient Rome and there's jet trails in the background. Somewhere in the middle is working together. And I don't just want to throw that up there and say like, good luck, work together, peace and love, figure it out. Some of the working together actually looks like darker satellites, timing observations differently, advancing astronomical cameras not to saturate as much as they do, circuit breakers on radio telescopes. We didn't even cover the radio aspect, turning satellites away so they're not as bright sometimes, or reflecting mirrors on those satellites to reflect the light away. I'm under no illusions that everybody wants to go to the Hill and everybody wants to do policy. So like, what can you as an individual do about this? The public is made of people. And it's a dumb thing to say, but I just want to remind you that like every person in this room makes up the public. And if I learned one thing on the Hill, it was that the public's opinion, people's opinion matters so much. Your politician wants to make you happy and wants to do what's popular where you come from. So it's kind of a chicken and egg. Laws will make the public change a certain thing, but pass way more easily when they're already popular. So the best contribution you can have to policy is showing the world what you love. It doesn't even have to be dark and quiet skies. Just whatever you love it loudly, because that is valuable information. Whatever is important to you, make art about it, write local news about it, dive deep into science, poetry retreats, photography, just celebrate it, tend to it, love it. Because people do notice and it does matter.